Hello and welcome to Donovan Evans Tutoring. I'm your host, Donovan Evans. We're continuing the series where we go over at least one question every day. Looks like today we're going to look at some things relating to heat, energy, so a little bit of a chemistry review. So let's see what we have here. So let's see if we can solve this together. So we present a situation where we want to know how much heat is required to raise 50 grams of water from 20 degrees Celsius to 50 degrees Celsius. All right. So when we're looking at this, let's see if we can get into the mind frame of what's going on. It's always good to try to look at things and, if you need be, paraphrase, rephrase so that you can better understand and organize your thoughts. So we know that we're adding heat. Maybe we're applying with a flame or convection, conduction, what have you. But we know that we're applying heat to water, right? And so heat we know is a form of energy. And so energy has been transferred from whatever that source is into this water. And that's represented by this change in overall temperature, what we observe, right? So what we want to look at is what parameters, what equations, and what information will we need to know, right? So what value and what equation are used to measure heat gain or loss, right? As seen in the situation, this situation, I'm sorry, is more so of a gain. So what equation is relevant? Give you a second. Hopefully you're recognizing that you are looking at your heat equation, and the specific heat of water is the value that's needed, right? So we like to define that as Q is equal to MC times delta T, so that Q being the heat energy, M being the mass of the substance. In this case, we're talking about water. C being the specific heat for the substance involved, and the substance in this case, as I said, is water. And delta T, that's going to be your T final minus your T initial. Let me actually make sure I write that on there. I always want to make sure I emphasize that whenever working with students, because sometimes we overlook the fact that your change in temperature, whoops, the change in temperature is best described as recognizing your difference in the temperatures, right? In terms of where you're starting, or where you landed, or where you ended, to where you're going. So what does that mean? That means that whenever we have a positive change in temperature, according to this equation, we were likely to see an increase in that heat energy, right? Versus if we see a negative temperature change, we're more likely to see, we're going to see, more likely to see, according to this equation, a negative heat energy. Now, I like to park there for a second just because, again, for chemistry, I always want students to be able to tell the story of what's going on, right? So increasing in temperature in a setting like this, that should be indicative of energy has been absorbed into the water, right? Into that system from the outside environment. Versus if temperature goes down, that means that that system of water, that the substance of water has lost energy to the outside environment, and that would make sense that Q would be negative, right? So thank you for enduring that rant. Let's go on to the equation and see what we can find, right? So let's remember to write down our equation, right? So let's remember to write down our equation. Hopefully this is a quick one that we can always remember. It's always going to be Q is equal to MC delta T. And as always, I always recommend the students over to the left, organize your thoughts by writing out your variables so that you can have an idea of what they are, and to see if you need possibly another equation in and of itself, right? So do we know Q? We don't, and that's okay, because that's what we're looking for, right? Do we know the mass? And in this case, we know the mass is going to be 50 grams, right? And in terms of specific heat, I usually recommend for students to write that out for the first one, right? Actually, make sure, yeah. 4.184 joules per gram degree C. All right. And I like to write this out, especially for our units, and I, specifically because whenever we write out our units. It can help us make sure that everything is in the right unit for consideration, right? So if you're in this topic, hopefully we're remembering that energy could be described as in either joules or calories, depending upon which system we're working with. We could also use specific heat or have a specific heat for a substance that is measured in grams or kilograms, right? Or Kelvin versus Celsius, right? So these are all the things they're going to keep that we want to keep tabs of in terms of the units that we're working with. So I always recommend as you're writing out your numbers, go ahead and place your units there as a reminder. Okay. And so in terms of our change in temperature, right? So as I said, that would technically be our T final minus our T initial. And in this case, that's going to be 50 degrees C minus our 20 degrees C, right? And so that should mean that we would end up with a 30 degrees change in temperature, right? So real quick, let's park for a second where we're looking at our specific heat. So what does that mean, right? So for the substances that might come into question in terms of energy added to them by heat or adding heat energy, we have been able to, scientists over a number of years, over centuries time, have been able to determine how much energy it takes to raise one mass unit per 1 degree C, right? So whether that mass unit is a gram or a kilogram, whether that temperature unit, I shouldn't just say degrees C, it could be Kelvin. Technically, it could be Fahrenheit, although I don't recall I've ever seen Fahrenheit written in specific heat. Nonetheless, the idea is how much energy does it take to raise one mass unit, one temperature unit? That's all we're going to think about, right? And so we can use this as a standard in this equation because once we put this information in, we'll be able to figure out exactly how much energy was added in this situation. So enough talking. Let's put the math together. So Q is going to be equal to 50 times 4.184. Oops, hold on. 184 times 30, right? So placing that in your calculator, we should get 6,276 grams. I'm sorry, joules. J. It's a better J. All right. Yeah, so 6,276 joules. And so from there, a general recommendation is that hey, if you know that you have a larger amount in terms of joules, converting that into kilojoules might be helpful, right? And so what does it take to go from a joule to a kilojoule? We're recognizing that we have to divide by 1,000, right? And dividing by 1,000 in this setting is going to give us 6.276 kilojoules, right? So that's how much heat energy we're going to say will be added to this particular batch of water, right? So in terms of getting to your answer, either one of these could be satisfactory. But depending upon what your teacher's looking for, depending upon what the problem is looking for, converting to kilojoules could be a safe bet. I'll also want to improve this just a little bit in terms of recognizing sig figs, right? So very quickly, sig figs is recognizing that the most important digits is going to reflect the significant ones that were shown in your original problem, right? So that's a wordy way of saying we only cared about 2 digits here, we only cared about 2 digits there, 2 digits there. So guess what? My final answer only needs to have 2 digits, right? 2 significant figures. So let me erase this portion here. And let's see if we can reduce this to the most important 2. All right, so the most important 2 in this case, starting with this 6, would be this 6 and then this 10th place, right? So it means I'll end my rounding at that 10th place. So my final answer is actually going to be 6.3 kilojoules, right? That 7 is going to make us round up. Awesome. Okay. So thank you for taking the time to join this video. That's going to be it for this particular problem. But please feel free to like, follow, and check out some more videos that are going to be on the way or already on the page. Feel free to contact me if you need any assistance. Happy to be of help. And like I said, please like, share, and subscribe. Hope to see you soon. And thank you for watching today. Have a great one.